All right. Hi, everybody. Welcome. Thank you for coming. Here we go in our second Spark. Thank you so much for coming to this session. My name is Kristen Welch. I'm the PTN facilitator from Los Angeles Unified, and I am here to introduce Atoosa Abascal and Alice Horiba. And they're going to do this wonderful 20-minute spark on noticing, wondering, building mathematical curiosity and thinking and curiosity. So without further ado, I'm going to pass it over to you.
Good morning, everybody. Thank you for giving up a Saturday morning and joining us. It's just wonderful to be with you, and we're very thankful. Today, we are going to explore an activity together that we're hoping is a match to today's theme around curiosity. And this activity is called Noticing and Wonderings. And really in 20 minutes, it's difficult to do it justice. However, you're going to get a copy of this slide deck. So any parts that we don't mention, you get to look at it later and kind of self-pace through it. Let's get started. In order to guide our work together today, we are going to center our thinking around this guiding question: how does a notice and wonder number sense activity support students' math understandings? And in accordance with today's theme around curiosity, I'm just going to add an additional question for us to think about. How does an activity like this create this kind of safe space for kids to be able to express their curiosities in a way that makes sense to them, and in a way in which we as facilitators honor their thinking?
Okay, and then for today's short little session, welcome everybody. We just wanted to have a base of what number sense is. I know we all understand that, but we just wanted to reiterate that it is really complex and it has so many layers, and it's rooted in all the standards of mathematics. And number sense really facilitates that problem solving, reasoning, and discussing mathematical ideas. So this is kind of our foundation, and we really want our students to become comfortable in number sense so that they'll be successful. And students with strong number sense, they basically have a sense of what a number actually means, and they can visualize in their heads about how much a number is. So how much is 100? They can actually visualize that, or they can see. And if we ask them, what does 1/4 of that look like? They can actually picture it in their minds. And so students that have strong number sense, really, it helps them and supports them during math because they can have a visual model and a concrete understanding of different quantities. And Atoosa.
Sorry, I was in the
That's
middle
okay.
of letting people in, sorry. We are hoping that this activity also supports students' number sense by giving them a chance to look at the world around them and notice quantities and numbers. And students with a good sense of number sense also have this understanding around the relative magnitude of an amount. So for example, I know what 100 people looks like in a room, and that's a lot of people. But when I think about 100 grains of sand, that doesn't seem like much at all. So students with a good number sense, strong number sense, can kind of see the difference in those magnitudes. The National Council for Teachers of Mathematics really has started to be a proponent of this activity and highly encourage mathematics teachers to include this in their daily routines. And they actually came up with their own characters, notice and wonder. So I kind of snagged those characters for our work today, and you can borrow them as well, I'm sure. But today we're going to look at an image together, and we're going to notice and wonder, be curious, and anticipate what our students might say or think about. So here we see a set of Legos. And as you're looking at this image, I'm going to ask you to go to the chat or feel free to unmute yourself. But we're going to first focus on, what are you curious about? What are you wondering about? what kind of questions might you want to ask as you're looking at this image? So we're going to post those first. Are they soft? Thank you. What are we going to build? Legitimate question. Will we be using these? How many dots are there? Are these normal size or life size? Will we get more of them? Such a legitimate question. Why are they arranged this way? Why are there two of each color? Are there other colors? Awesome. So as a teacher, I'm going to post these questions. I'm going to anchor your thinking on chart paper. And then we're going to talk about, well, what are some things that you notice about the image? And a few people already have entered some of those ideas. Like someone said, I noticed there are equal sets. And so if you want to unmute and tell us more about that, I'd love to hear more. Where do you see those equal sets? And anyone else who wants to add to our friends' thinking, if you also notice it, go ahead and unmute or raise your hand, and we'll call on you.
So some of the, I guess, similarities is that there are two 2x4, I guess, are plates of each color. So there's 2 yellow. So a total of 8, I guess, dots, or, and I think Lego likes to call them 2x4s.
Okay, so you
Yellow.
see 8 of those dots on one yellow, and you see 8 on another one, and you're describing them as 2x4s.
Yes.
Can anyone else tell us, where do we see the 2 and then by the 4? Where do you see that? And I know on Zoom that's a little hard to explain, but that might be a question that I might ask next. So Alice, could you just circle what someone might say is a 2 and then the 4, and then can we label that with a different color possibly? And while she's doing that, can someone else tell us what else do you notice as you look at this image?
There are 6 of those 2x4, so you could do 2x4x6.
Mm-hmm. So there are 6 of those 2x4s, right? Can anyone think about an equation that might match Ms. Roberts' thinking?
I think someone put in the chat, but it was 2x4 by 6.
By 6, thank you.
Yeah. Mhm.
Yeah.
Anybody else notice anything else? We're
Let's
good to
get
go.
one more.
Mm-hmm. Anybody else notice anything else?
What might your students say?
You can also see rows of 12, or no, 8. So there's 8 on the top row, then 8, and then 8, and then 8, 8, 8. So there's,
Oh, so this whole row right here?
yeah, there's 6 rows of 8.
Oh, nice. Okay.
So like an array.
Could
Mhm.
we think about an equation that might match that thinking? You can put that in the chat for sure. Yeah, 6 times 8. Yeah. And so as a facilitator, I might ask the students if those 2 equations, 2 times 4 times 6, is the same as 6 times 8. And I can make that choice. Do I really want to go there in this sitting? Maybe I only got 15 minutes, or do I want to do a true false statement the next day with these two equations? You're going to get a wide range of ideas. In our last session, some teachers mentioned, if we could go back to the image, Alice, some people mentioned, oh, I see yellow Legos, I see blue Legos. So you might get some statements, starting from TK all the way to 5th grade, you're going to get a wide range of ideas, right? Some people were wondering, are those dots? What do we call those dots? So then things like vocabulary are going to come up, which is really huge for our ELLs, right? So let's take a look at what students in a classroom came up with as they looked at this image, and you're going to notice some similarities between the things you came up with and what actual students had to say about this image. And as you can see, they do have some wonderings that is about vocabulary. What are those things called? Are they thingies? Are they studs? They will notice things about the colors. And then, of course, soon enough, some equation work is going to come out of this. And again, depending on the grade level you teach, right? So for primary grades, it might be adding the pegs on one Lego, either by 2s or 1s, all the way to 5th grade, in which you're going to come up with a variety of equations. Alice, did you want to add anything to that?
No, that was good. Thank you. And then we also just wanted to make sure that how this connects to the Common Core standards, because I know a lot of districts, they want to, your admin might want to make sure that, what are you doing? Why are you just talking about a picture? And so we wanted to really highlight that it does connect with the standards for mathematical practice. And even though it does go to every single standard in that in the practices, out of the 8, we wanted to highlight the 2. So number 2 was reasoning abstractly and quantitatively. And then number 3 was to construct viable arguments and critique the reasoning of others. And so really having students talk about something and having other students question that or ask questions like, I don't see that, or where do you see that, or what happens here? And so this is really how we can connect that Common Core standards into our mathematical practices.
And reflecting back to our original guiding question around how does Notice and Wonder support students' mathematical understanding, we came up with 8 statements, and I'm sure that we could come up with a lot more. But we want you to take a moment to read these 8 statements on your own. And if you could drop in the chat the statement that most resonates with you as an instructor. And if there's more than one, definitely put more than one. Thank you. Number 1. Yeah, number 6. That differentiation of learning experiences. Thank you. Number 4. It does elevate their growth mindset, right? Because everyone has an entry point into this activity. Even if I just notice that there are 2 yellow Legos. Thank you. Number 8, vocabulary.
Yeah, it does span all of them. Yeah. Okay, and then we also wanted to give you, we will share the slide deck with you. We also wanted to give you just any sample images of anything that really is going to pique the interest of your students and also have something that you want to bring out mathematically. And so there, at the end of our presentation, we will share the slide deck, as Atoosa said, and in there's going to be a resources page where we've linked some of these websites where you can actually get pictures like these so that you can actually use them in your classroom. I know in the last session, a teacher told us to also, she gave it to her students and said, take pictures at home that you think might, what do you notice and wonder about? And so you can also incorporate students bringing pictures back from their house if they see something as well.
And as you're thinking about the images, begin to anticipate what might my students say when I show this to them, so that you can begin to gather that information ahead of time. If there isn't much that students might notice, then it may not be the right image. But also know that this work isn't necessarily one and done in one session with your kiddos, because we know throughout our day, we might have pockets of 10 minutes here, 15 minutes there. And so once you show an image, you may not finish all the way. You might just do it for about 10 minutes, come back to it the next day, come back to it the next day. So don't feel this pressure that I have to, do several images within 1 week. One image might last you a few days.
And that kind of brings us to some teacher tips and considerations. And I know Atoosa did hit on this, as it is a great entry point for everybody, but also just making sure before you start this activity is to really define what those things are. When we ask students to notice something, what does that mean? Or when we ask students to wonder, instead of just starting it cold, because you might get things that you didn't anticipate and you're like, where did that come from? But also you want to make sure that they understand what that is. And also we notice that this also doesn't apply just to mathematics. It applies to when you read books. What do you notice about the author or the characters? And so this actually is really good practice of just noticing and wondering, and having the kids, giving the students voice of when they notice something or when they wonder something, even in science or social studies.
And as practitioners, we want to be reflective on our work. And so this slide is just encouraging us to take a step back during the activity and think about really who's doing the heavy lifting of the cognitive work. If we find ourselves being the ones who are having to unpack an image, ask the questions, and then answer our own questions, or ask leading questions, then we know that we're doing most of the work. But if students are having this argumentative attitude around the mathematics, and they're arguing with each other, they're pushing back on each other's thinking politely, and justifying their thinking, asking questions, making those wonderings, then they are doing the heavy lifting, which is positioning them in the right place as mathematicians. So this is really a reflective question for you. Having experienced today's short presentation, when might be a good time for you to facilitate such an activity in your classroom? How can you make this a regular routine in your math class?
And then we also wanted to just let you know we do have a resources page. And so we will be sending the link in the chat so that you can actually get our slide deck. It should open. We had a little difficulty last time, so if you want to just click that, it does save directly into Google for you. I know Kristen just said we have like a minute or so. We wanted to thank everybody for joining us this morning and for attending this session. And if you have any questions, we can take like one, maybe. I don't know, Kristen.
Yeah, one question while I look for the link maybe to the next Zoom,
Yeah.
but it's the same link.
Right. But thank you so much for everybody for attending, and happy noticing and wonderings.
Yeah, we'll see you at the next keynote. This was beautiful,
Thank
ladies. Well
you.
done.
Thank you.